Hey guys, what's up? Eddie Aho here with KissAnalog.com. Alright guys, so I kind of changed my reviews a little bit on the oscilloscope. I have this Uni-T UPO1204. It's a pretty amazing scope. It's like what they've done is, you know, the Siglant, the two-channel scopes, the 1202, 12, I have one back here, the X. Now they have the X-E, and then Rigo had theirs. So those scopes that came out 3 or 4 years ago, God, how long has it been now? 5 years ago? I think it's been, yeah, something like that. Well, so 8-bit scopes, right? Which a lot of scopes are. And I mean, it was just a common thing, unless you're spending 10, 20K. But right here, the Uni-T, still 8-bit. So there's a 12-bit scope Rigo put out, but once you turn on 2 channels, the deep memory drops way down. And once you go to 3 channels or 4 channels, it drops down to 1 meg, which is not deep memory anymore. So the 800 series, I think you have to go to 900 series so it doesn't do that. And then you're talking about, especially with the 200 meg scope like this, if you're comparing apples to apples, it's like $200 more than what you're paying for this one. So do you want deeper memory, faster refresh rate, maybe a better FFT? I'm not sure. Haven't been able to use a Rigo, but this FFT is pretty amazing. So let's take a look at this, okay? Let's bring the camera over, take a look, see what we think of this scope, and see the FFT is just something that I remember when Tektronix came out with their lower line scopes, like the $5,000 scopes or something. They had these little modules you'd plug in. The modules probably cost as much as this scope. And they weren't as powerful as this FFTs on those. They were almost gimmicks. But spectrum analyzers are amazing. If you've seen my videos on spectrums where you can see the spectrum versus on an oscilloscope where you see things, the voltage moving over time, right? So if it's a sine wave, you see a sine wave, right? If it's DC voltage going up and down, you see that. So, oscilloscopes are awesome. You get to watch things over time. But if you want to see things, how many frequencies, like let's say you have a 1 kilohertz signal and it's got distortion, harmonic distortion. It's nice to see a spectrum where you see, oh, here's a spike at 1K. It's a 1 volt. That's what I expect. Oh, but look at these other spikes. That's my harmonic distortion. Oh, and there are these frequencies. That's nice to see. And so spectrum analyzers are great for that. FFTs are great. It's a way of kind of giving you that spectrum analyzer look, that frequency domain in an oscilloscope. So I want to show you how that works over here, okay? So let's come over, and I'm going to kind of show you the MIG and the GW Instack up here, just so you can kind of get a feel for what the screens look like. And I'm going to show you some cool features, and then some things I think might be bugs or not so cool, but I think are going to be easily fixed in firmware updates, I hope. So I've sent Uni-T an email, and we'll see what they come back. They said, hey, we're going to check with our engineers. So, hopefully they'll look at this video and they'll go, yeah, we need to fix that. Or maybe they'll say, or, we'll see what happens, okay? But they've been very responsive and very great. So, all right, I'm going to show you. This is part of the review of this scope. Hope you find it interesting. Give me a thumbs up if you like this video, okay? Appreciate it. Subscribe. All right, guys, come over to the bench. All right, guys, so we're going to use this Uni-T generator, and it's a sine wave, 60 hertz, 1 volt RMS. Okay, that's our signal. We should see one single spike. If it's perfect, no harmonics. All right, guys, so now here's the GW Instack. We're seeing 60 hertz, 1 spike. So that's great. And it's at 0 dB. So that's what we want to see. Okay? And it looks pretty clean, right? All right, guys. Sorry about all the glare on this one. It's such a shiny screen. But here's the MIG. Awesome. Love it. There's 0 dB. But look at this. We are seeing some harmonics way down here. Now, guys, this is like 100 dB here, 80 dB. So it's like 90 dB in the noise floor. And we're seeing harmonics way down here. And they're below 80. So they're like 85 dB. So that is that's pretty clean. So that's probably why we didn't see him show up on the GW. Coming back here at the GW, just to point out, here's 80 dB right here. And look, so that's probably why we didn't see them. They're down the weeds or down the grass. All right, let's see if we can clean that up. Here's center frequency, 500 hertz, spans 1 kilohertz. That was the same as mixed sig down below. So bandwidth, we can go, and we're at 1 hertz right now. So can we go in? No. And span resolution bandwidth, we're going as high as we can. So, okay, we're Blackman, same as mixed sig. So, I thought we were going to be able to improve it. That's why I brought you down here to show you that. But, okay, so nope, there we go. Actually, my mistake, I had it on off, so I turned it on. So now it's collecting data, and we see a few of those little spikes. Here's 90 dB, so it's only down, well, 60, 80, so that's 80. So that's why we're not seeing it. For some reason, I don't have the same resolution bandwidth on this one. All right, so here we are at the Uni-T, and look, it looks more like the mixed sig. We got the spike, and it's just below 0. Now here, that's one of the bugs I want to tell you about, okay? So it's only going to about -5 or -10 dB. That's because I'm using a ×10 probe. Here, let me switch it to ×1. All right, so now we're up to 0 dB. I went back to channel 1 and I set it for ×1 probe, and when I did that I had to readjust this because it went off the screen once I did that, so I had to bring it back in the screen so we got a good measurement. And once I did that, now it says 0 dB. So now it looks like the mixed sig. So this looks just like the mixed sig as far as I can tell. This looks like 80, 100 dB, we're around 90. So this one agrees with the mixed sig. For some reason I couldn't get the GW to agree with these two scopes. So there you are. So now just point out a couple things. I can turn off the menu. Unfortunately, in other screens, it'll fill up the screen. In this screen, it doesn't fill it up. It just keeps this square. I wish it would fill in the screen when I got rid of the menu. Also, this table right here, it's nice. It shows the first 5 harmonics. So you can see the little arrow here. And let's see, where are... All right, I zoomed in a little bit so you can see a little bit better, but you can see an arrow here, and I'm not sure where the other ones are. It says, oh, 6 hertz, 4 hertz. Oh, they're all on the DC. Yeah, that's why, because sometimes they do that when you're at the low frequencies. So we got a harmonic here, and here's a table. But so here's the thing that I wish would happen. I wish this would fill in the whole screen and I would not get that table until I wanted it. So I can go to menu and I can go back here and I go to this is detection mode. So I can say what I want detected. Okay, go back here. I can say mark, and I can say, okay, mark the first 5. And that's what's happening now. I can make it higher. See, I go a lot higher. See all the little arrows that popped up? I'm marking the first 22. I'll go down until, okay, first 16, going down. Okay, there we go. So if I go around 11, I can see a bunch of markers. So that's awesome. It automatically sets markers, and I can tell it, you know, what level if I want to do it. Now here's a marker list. I can go on, and it gives me the list. So I don't need that list over here. I want this to fill in the screen when I'm like the mixed sig, like the GW does. I wish it would do that because it is such a powerful FFT on this. I'll show you something else it can do. So I've shown you some problems, right? Now let me show you something else it can do. So one of the problems is that if I get rid of the menus, it still shows me this. It shows me this list, even though maybe I don't want to see it. Maybe I just want to see the dBs and I want to see the frequency. I see 3 spots here, but I would like to see the whole screen filled up, right? Okay, now here's another thing. I can turn the menu back on, parameter set, and I'm at mode. Okay, here's source, Windows, I'm at Blackman. Here, I'll go through these so you can see them, okay, just so you see the power. I can choose one of those 4 channels. I can go to Windows, and I can choose Hanning, and I got all these options. We're going to go to, just because I'm doing all the other ones with Blackman, we're going to do all Blackman this time, okay? Vertical units, decibels, or volts RMS. I want decibels. Most often you want decibels. Points, I got 1 megapoints. But I can go less. I can go all the way down to 8K if I want. So anyway, I'm going to go to 1 meg. And I love this knob. It works really well. You see me up here in the right corner. It's really smooth. It's not like the, if you guys ever used a Siglant, you know what I'm talking about. This one's really smooth. So here's an independent. Now watch, I'll go to split, turn off the menu, and look at this. Now we got to wait a moment. Now here's another thing that's not an awesome thing. It takes a moment for this to refresh, you know. Oh, now here's the thing. See, I'm seeing the frequency. See, I'm looking at my scope mode. But how come I'm not looking at my FFT? It says 1.25 meg. That's a problem. That's another bug. I have to endlessly keep going back to this. Now I'm going to show you a workaround. Oh, here's another thing, by the way. When I'm at start frequency, when I'm highlighting on that box, I can use this thumb dial and I can pull up and I can change this thing, okay? Go down 0 hertz. Now, what I could do, let me show you options. I could go to bandwidth. And this is what's cool. This is like a spectrum. I could go bandwidth, and I could go frequency select, or center frequency, and I can set the center frequency, say at 500 hertz, and frequency bandwidth 1 kilohertz. So I could set it up that way. Or I can do start and stop range. Okay, spectrum analyzers, it's common to do it the other way, but start and end is, you know, something that's easy for a lot of us to know. But when you're looking at, say, a 10 meg and you want to see 1 kilohertz on either side, the other method's a lot better, okay? So anyway, here we go. So I have to set that 1K. Now, it takes a moment, so that's another thing. The speed of this is a little bit slow. Now, I can use this position thing, knob over here. Let me turn the camera. I can use a position knob to adjust this, but I'm going to leave it for now because we're going to take back the other screen. And I keep thinking that's going to be a waterfall or something. I'm not sure. I haven't been here, honestly, I haven't been here long enough to see that do anything, but it'd be cool if that was the waterfall. Now, if you don't know what a waterfall is, let me show you. Now, here's a tracking too, okay? I can turn tracking on, okay, but let me take you back. So here's back button again. Okay, parameter set. Oops, I was already there. Right here, mode select, push the button in, and go to full. Okay? Now hold on a second. It takes a moment to update. This is the screen where it shows you both the frequency domain and the time domain. Time domain's the yellow, the normal scope mode, right? And the frequency domain's the signal. I'm not a big fan of this one because it's hard to see one over the other one. It'd be neat if you could fade out like one or the other one, right? So you could fade out one so it's just, and you can do it, I guess. You could change the display intensity. I don't know. You could play some tricks, but it'd be just neat if you could fade one out, fade one in. But this isn't my favorite window, but the nice thing about it, look how big it is. If I get rid of the menu, look, it uses the whole screen. I wish the third option, when you're only seeing the frequency domain, I wish it would keep this same screen, except for show that. I don't know why it shows you the list when you have the option of pulling up the list. So that's a little bit more of a frustrating. Maybe it's a personal thing on my side, but that's just me, okay? So let's go back to parameter setup. But the point is, I guess I'm being spoiled. I mean, the spectrum on this is way nicer than, like, say, the Siglant or the old Regal, right? So it is much nicer than that. Okay, there we are. Oh, we're still kind of up high. Oh, you know what? What's happened, reason why, is because when I changed it times 10 to times 1, and I had to adjust the screen size, I didn't change the volts or the decibels per division on this when I went back to decibels. So there's 20 dB per division. Now what? Wait for it to update. There, now dropped down, okay? Now see, it has to acquire a few cycles before it gets good waveform, and this one disappears. There we go. See, now it's 0 dB, and it looks like the mix sig, so we're back to there. But every time I change something, I lose the frequency. If I go to any button on the screen, But here, let me show you something. Here's the workaround. And I showed it in another video. Do the freeze. Now, if I go to parameter, and if I go, oh, I want to change to split again. I want to show you split again. So get rid of the menu. And now I'll pull up the frequency just so you can see, look, it's still 1 kilohertz. If I wouldn't have froze that button, it would have went back to the default for this. And the default for, it depends on your horizontal position, how many things you've captured. And I'm going to talk about that in a moment too, to give you a tip on how to capture that, okay? But it depends on this and how many mega points how many points you're collecting and all that. And then it does the math, and then it does everything, and it defaults to the widest bandwidth you can get. But if you don't want the widest, like I want 1 kilohertz right now, because we're only looking at 60 hertz and I want to see all the harmonics, I go to this window. But this window right here, I don't really see the value yet. Honestly, I haven't spent enough time to figure that one out, but yeah, I don't know the value of this window. I wish it was a waterfall. Oh, I was going to show you the waterfall, right? Okay, so let me take you back to the waterfall. What you do is you go back to this one, so parameter setup, and see when I'm in this window right here, and I click on it, see how there's a waterfall down here? Here, I'll zoom in. Okay, I'll zoom in a little bit so you can see. So the waterfall is not highlighted. The reason why, and I wish it would let you go down there and select it. And once you selected it, it would say, hey, we're going to change the point so that you can have this. Instead of just not giving you it and not giving you any idea of why you can't do it. But here, the reason why you can't is because we're at 1 megapoints. And that's too many points to do a waterfall. So if you don't know what a waterfall is, I'll show you that here. Let's go back to this. Whoops. I'm going to go points, and maybe 512 will let me do it. I'm not sure. Let's go to waterfall again. Parameter. Whoops. I just have to push this again. No, I can't do it. Okay. Geez. 64 or 32. We'll go down 32. Hey, I can do waterfall. Holy smokes. In waterfall mode, FFT maximum point is, wait, what did that say? Oh, there's 2 waterfalls. I didn't know that. Oh, wow, I don't know the difference of the 2, guys. This is the first time I saw it. Okay, we'll go to waterfall 2. I don't see that message again. Okay, I have to go to frequency. See, it's back to 12K now. Let me go back. Okay, start. Let's go 0. See, I can't change it with the dial. I have to go this way. I have to push it again, and I have to do it this way. I wish it would let me use the multifunction dial to change this one like I can the low limit. So I think that's another bug. So I think Uni-T, I've kind of talked to them about a few of these things and waiting to hear back. They said they're going to talk to their engineers. Okay, it's 11K. I must have double hit the button. Let's go back to 1K. Okay, 1K. Okay, now here's the thing. We're not going to wait to do this because it takes too long. I'll get rid of the menu. See? Wasted space and wasted space. And I guess they decided, hey, let's just put the first 5 markers. You know what? If I'm stuck with that, why not start it up here and show me as many markers as I can all the way down the screen so I don't have to go turn them on, right? But now see what's happening is we see the spectrum here, right? What's happening is the waterfall is going from bottom to top, and where this one's a strong signal, these are weaker. We're going to see a strong line here. Eventually, you end up seeing this whole blue thing fill in the screen. We'll have a real bright line here, less bright, where all these things are. And so if you had something sporadically jumping, popping up here, popping up here, popping up here, maybe one popping up there, you would see these little dots and the thing. So you'd have this blue screen, you have these little dots, maybe 1 or 2 dots. You have a real bright line here, a weaker line here, and you can kind of start seeing the lines here, okay? I showed this in an earlier video when I kind of showed the Uni-T, the box opening, and I just walked away and came back later and showed the screen. But you can see this one's, maybe you can see it's kind of reddish right there, right in the middle. I don't know if that's showing up for you, but Yeah, so that's the waterfall, okay? So that'll take us, you know, quite a while for it to fill in that whole screen. The idea of the waterfall is it's kind of like it's kind of like one of those. Okay, guys, here, let me zoom in on that. I went ahead and let the waterfall go, and so you can see the bright orange kind of green lines for this big spike. This spike's the next biggest one. It's kind of the darker line, and you know, anyway, you can kind of see. Now, if this line was going on and off, you would have saw a dash, dash, dash. So that's what a waterfall does, is over time it shows you what's happening at all these different frequencies. And yeah, so that's a really cool feature. It used to only be offered on spectrum analyzers that cost like thousands and thousands of dollars, but now you get on a really nice FFT. So yeah, I think Uni-T's done a nice job. There's just a few things I think they need to fix to make it perfect. All right, guys, so just go over a few things just to give you a good idea how to use the FFT and how it all works. Here, let me zoom out so you can see the whole scope front, so you can see the controls I use. Okay, so here's the thing. I just turned on a square wave, okay? So now you're seeing all these harmonics a lot taller, right? So a square wave is actually a whole bunch of different sine waves to make a square wave. And so this is all the different sine waves, all the different frequencies and the amplitudes, okay? And look at all the diamonds. And so it shows a little list here. So if I turn on the menu, I can go, let's see, go back to menu, the marker menu, I can go list, and I'll just turn this on, push that button, look at that list. So here's the amplitudes, and here's all those frequencies combined make a square wave, okay? And so we get to see that on this. Now here, let's go back. Let's go to parameter setup. Let's go to waterfall here. Well, and before I do that, let's see. If I'm in waterfall, see how it won't let me go bigger than 64K? So that's how I know. So now if I go back to the one interesting thing is this waterfall 1 and 2. I'm not sure what the difference is. Well, I don't know what the difference is. I didn't know there's two different waterfalls. So, but yeah, there we go. So here's the frequencies. Now see, it changed my frequency to 12K again. That's so frustrating. That's one of the problems. To lock that in so it doesn't happen before you start changing things, just lock this in, make all your changes. See here, I'll show you. Let's lock this in 1K. Okay, now I'm 1K. Now I'm going to lock this in. Now I can go and change a bunch of stuff. I can go back here. I can go to parameter setup, waterfall. I'm going to go to independent, the screen I typically like, except for I wish it was bigger. And then I go to frequency range. Look, still 1K. If I wouldn't have froze that, it would have went back to the default, which is so frustrating. So anyway, so we're back to here, and I'll turn off the menu. Unfortunately, yeah, I've kind of already talked about that. So I'll turn this on, and we'll start collecting data. And it is, the one thing about the FFT on this, I gotta say, it is kind of slow. The refresh rate is pretty slow. Maybe it's all the points it's taking. Maybe it's the deep memory over here. I'm not sure. But there is some math formulas based on the horizontal, like how many waveforms you're taking on your horizontal versus how much, see if I go to acquire, like the memory depth, I'm only at 7 meg depth, so I'm not very deep. I go to 56, I go to auto, and I've tried different ones, and I haven't really seen a big difference. But based on all these things, and then how many mega points you get on your here, let's go back to that menu, parameter. See, we're 64K. Now that I'm not on the waterfall, I can go down here and get more points. The advantage of that typically is when you're doing a spectrum, well, hold on a second, where's the spectrum? I want to make sure I'm dB volts, channel 1, all this stuff, okay? So let's go back here. Oh, frequency range. Ah, crap. I should have froze this when I did all that. See, it went back to 1.25 meg. So, I think when I change how many memory points, it makes me take it off that. I don't know. God, it's so frustrating. That's one thing Like, why, when I say what my end frequency is, why does it keep on going to some default thing? What it's doing is it's using the math of all those things I was talking about, and it's saying, oh, we can go all the way out to 1 meg. But I don't want to. I said I wanted to go to 1K. Urgh. So anyway, that's a frustration. Okay, there we go. So see, when you get these high TP things, instead of being sharp spikes, that's when I feel like I need to go to more mega points, which I do. But I have 7 million points here. I'm going to try to freeze this. I don't think I can do this. I'm going to freeze this. I'm going to go to acquire, and I'm going to see if I can go to, yeah, see, I can't do it. Invalid because I'm stopped. So dang it. Okay, I'm going to, okay, see how wide they are? Let's see if it fixes it if I get more memory points. So now I can go to memory points because it's running over here. You go down 56 million. That's crazy. Such deep memory in this scope. It's just crazy. So we got 56 million. We're going to go back to our FFT. And frequency range, look, 1.25 million. Huh. Who would have guessed that? Okay, whoops. Let's go back to 0. Remember, that's another bug. I feel like it's a bug. I can use my multifunction, change that frequency to start, go to and, doesn't change it. Nothing. That's, I feel like that's got to be a bug. So 1K. So I think in firmware they can fix these things, and then we'll have a really amazing FFT on an oscilloscope. Okay, now I don't see the TP things getting that much sharper. Okay, there's one more thing I'm going to show you that we can try to do. Right now we're at 200 milliseconds per division over here on our horizontal. Now we're at 60 hertz. Basically it's 16. Let's just round it off. If you're 50 hertz in another country, it'd be 20 milliseconds for a cycle, right? So we're at 200, roughly 10 times that. So maybe we have to go higher, so more time. So see, here we go. They're not very wide. I mean, they're kind of like TP shape. They're not spikes like I would want to see if I had. The resolution I'm talking about is how many hertz of resolution. So if we're, say, 100 hertz versus 1 hertz, right? The spectrum analyzer, I can go down to 1 hertz, the Uni-T, which is amazing. But I feel like this is pretty wide. So all the information in this width of frequencies right through here is being added up and making this spike. And anyway, so the noise floor, also noise floor usually drops when you drop. So 80 dB is here, hundreds here. That is ridiculously small. So already we're getting exceptionally great waveform. I'll zoom in so you can see this. All right, see that? There we go. Okay, so there we go. That's pretty amazing waveform. Okay, let me zoom out again. Okay, so here, let's go. Now I'm going to try to do this, run stop, and I'm going to try to change this, see if I can. Okay, I could. It went to 500 mil. So I need to get more cycles, 500 milliseconds, more cycles to try to get the resolution. So I'm going to turn this back on. Oh, look. See, even though I had it froze, that's the one case where I've noticed that. If I change this, it still changes that. It scales it to this. So that's the one time that it doesn't lock that when I have the red button on. So, I mean, in red instead of green. So I still have to come 1K. 1K, and I think we're going to get a narrower spike when I do this. Yep, look how narrow they are. So there you go. That's how you can narrow it, is getting basically 10 to 20 times the cycle time. So if the cycle is, say, roughly 20 milliseconds, 10 times would be 200. Gives you a pretty good waveform, but double that again and 500 milliseconds, you get a lot more waveforms on your time domain, and then it gives you more math and it gets more points and all that. And look at that. Right now, see all these markers? We got down to that many markers. And if I go back to here, turn on the marker list. So look at all those markers we got, right? So that's pretty cool. Now, I could see, I got 11 chose right now. I could go more. And it should go down here, I think. Let's see. Oh, I'm at stop. Let's turn that back on. Okay, I think we have to wait for it to refresh because 500 milliseconds is a half a second, right? So it has to capture a few of those, do the math, and... oh, there we go. I was about ready to give up. Now, it looks like there's some extra spikes next to those spikes. I'm not sure if those are valid spikes. It might be... we might have to wait for another update. Oh, there we go. There we go. Okay, so it just took a couple updates. So now let me go back to the frequency. I wonder if it changed my frequency. No, I'm still 1K. Okay, so that was great. So just because I went to markers, but almost everything you do, it'll change your frequency. So you always have to come back here and check your frequency to see if it's still what you want. See, now look, I'm going to leave that on green. Now if I locked it, it wouldn't screw me up, but since I'm not locking it, watch what happens. I'm going to go to range and say, oh, what if I wanted to do bandwidth control instead? Now it says 500 hertz center frequency, 1 kilohertz. That's where I was set. Perfect. Now if I go back to range, wow, okay, for some reason it didn't change my frequency that time. Kind of shocked, actually. Okay, I was waiting for an update, but yeah, there you go. Looks nice. So that's a square wave. You see a lot of harmonics. That's the way a square wave is supposed to look. So that's the cool thing about an FFT. You're not looking at one frequency. If you have one frequency with a bunch of noise, like say a square wave, you'll see all the harmonics you're getting. This is essentially noise across your frequency band with the square wave. On a sine wave, you expect to see one spike and nothing. So if you see little things, you go, oh, that's because I have some harmonic distortion, which is THD. Total harmonic distortion is adding them all up, right? So there we go. Hope you like that. I think I showed you some flaws, some cool features, and I think, you know, I'll keep you up to date. Uni-T comes back. They're checking with their engineers right now. So I don't want to make them feel bad that I'm showing you this, but you know, it'll give the engineers, if they don't understand what my email was all about, they can see what we're talking about here, right? Okay. All right, guys. So the one tip I gave you was if you're looking at a particular frequency, 60 hertz in this case, it's you know, or 50 hertz. It's 60 hertz around 16 milliseconds for a full cycle. 50 hertz is like 20 milliseconds, right? So times that by 10, get enough cycles on the screen that the FFT can do enough math that it can come out with some nice sharp pictures, okay? So multiply by 10, really multiply by 20. I think I showed you that, right? And then what happens is depending on your, like this one has 2 gigasamples. That's another really cool about this thing about this scope. It starts off at 2 gigasamples per second. That's pretty amazing. 200 meg scope. But anyway, you start off with that, you know, 500 milliseconds. And then what you do, now it's got a bunch of cycles it can look at. And then what you do is you go in there and you set up all those other things you want to do. And you set up the frequency. What's really nice about this FFT is kind of like a spectrum, which GW calls their mixed mode scope, a spectrum analyzer, and they have the FFT on that. So really on a spectrum, you get to say, hey, I want to look at this frequency at 1 kilohertz. So you say, I want my center frequency at 1 kilohertz, and I want to see what happens 200 hertz on either side. Or I want to set it at 10 megahertz, my clock, and then I want to set it at 1 megahertz on either side. So my span's going to be 2 megahertz. So that you can do that with this. You don't have to, like the Siglent, the old Regos, how you had to play around with them. You can just say what you want and you get it. That's a really cool feature. The bad thing is for some reason it doesn't lock in. And then also the multifunction button doesn't work on the higher frequency, only on the lower frequency band. Because you also have that option of setting the low frequency, say at 0 or maybe at 10K. and the high frequencies at say 50K, and you want to see what between 10K and 50K. So you can set it up that way too. So, but the multifunction button doesn't work on the high one. You have to push the button twice, and then you can go in there and use the multifunction button to select what frequency you want by going through their table. Okay, that might be the faster way to do it, but it'd be nice to have the option. So anyway, those are a couple of things I think are issues. The biggest one is how whenever you go change other settings or you go look at other things, how it changes your high frequency setting. That it's like, no, don't do that. So there is a mathematical thing where you have so many points you're collecting, and depending on the bandwidth and all these kind of things, that you can only get so much, or you can usually get less, but you can't get more than what the points are going to give you. So if you're trying to go beyond the limits, it should just give you a warning. Say, hey, you can't do this until this. Or when you're trying to do the waterfall thing, you're like, hey, how come it's not highlighted? It should be highlighted, I think. And when you go select it, it says, we're defaulting you to, 8K points instead of 1 meg points. If you want waterfall, that's what you get, So I think that'd be a better way to do that in firmware. So just some of my ideas. But anyway, guys, what do you think of this video? I like this scope. It's really nice to use. I like the feel of it, the knobs and everything. It's very user-friendly, and I'm showing you the tough parts, the FFT. That's the thing where oscilloscopes, the MixSigs done a great job. That GW costs quite a bit more than, it costs more than both these scopes together. So it should be nice, but there was an issue with that. The GW I didn't see, which is kind of crazy. I didn't see the same resolution I saw on both of these, so I'm not sure why. Maybe I didn't have enough cycles collected. Maybe that's what it was. I need to, but I was in spectrum mode. So when I'm in spectrum mode, I don't normally have to worry about that. So I wasn't in FFT mode on that. Anyway, all right, guys. Thanks for watching the video. 2 thumbs up if you like it. You can't do that, but you can give me 1 thumbs up. I appreciate that. There's a super thank you button if you want to buy me some coffee. I got to get up really early tomorrow for work. Yeah, we got a really cool thing we're going to do at work, so I got to get up early. But I wanted to get this video work done. So, all right, guys, thanks for watching. 2 big thumbs up to Uni-T for sending me out this scope, and also 2 thumbs up to my members of my channel and to Timothy for being a team member. Way to go, man. Appreciate that. And 2 big thumbs up to my patrons as always. Thank you, guys. Appreciate all you guys. And yeah, thanks for supporting the channel. It's kind of cold in here, so I'm ready to power down and get out of here and go to bed and get up tomorrow. Thanks for watching, guys. See you next time.